Okay, so we are going to see that this differential equation is a homogeneous, or we are going to prove that this differential equation is a homogeneous function and we have to solve it. So how we do this is, first we take this x minus 1, we write down the given differential equation x minus y equal to times of dy by dx, x minus y times of dy by dx equal to x plus 2y. We write down this in the form of dy by dx equal to f of x comma y. So this can be written as x plus 2y divided by x minus y. Okay, which is nothing but I can write down this as f of x comma y, i.e. f of x comma y. I know that f of x comma y is equal to x plus 2y divided by x minus y. Now since I have to prove that it is a homogeneous function, I'm going to apply first method, that is lambda x and lambda y method. So I replace x to lambda x and y with lambda y into the f of x comma y. So therefore this will become f of lambda x comma lambda y. This is equal to lambda x plus 2 times of lambda y divided by lambda x minus lambda y. So this is going to give me, I can factor out the lambda from both from the numerator and denominator. I will get x plus 2y divided by lambda times of x minus y. Now we can cancel both lambdas. Okay, like this, I cancel, and finally I can find out, I'm getting as, after I do the cancellation, I get this is equal to x plus 2y. Since I don't have any lambda without any powers of lambda, I write down as such I have a lambda with power 0, and then x plus 2y divided by x minus y. Okay, which is in fact nothing but lambda power 0, our original function f of x comma y. Okay, so I can see that f of lambda x, so therefore we can observe f of lambda x comma lambda y. This is found to be lambda power 0 times of f of x comma y. So after, even though if we replace the function x and y with lambda x and lambda y, we are getting back the same function with some degree of lambda. Here the degree is 0. So as we know that the differential equation is a homogeneous function if the function is homogeneous with the degree 0, which we can clearly see from here. So therefore this is our differential equation. Our differential equation is homogeneous with the degree 0, or you can simply say it's a homogeneous differential equation with the degree 0. Okay, with degree 0. Okay, so now we are going to understand how to solve this differential equation. dy by dx equal to x plus 2y divided by x minus 2y. Let's do from here. dy by dx equal to x plus 2y divided by x minus y. Okay, let's just confirm x plus 2y divided by x minus y. Okay, so this is the homogeneous differential equation which we already proved it. So we make the substitution y equal to v dot x. Then we differentiate this one. Let's consider this as 1, and this also you can consider this as 2. Now we differentiate equation 2, dy by dx equal to, since v is a function of x, here we have to apply the product rule. Okay, so which will give us v plus x dv by dx if you apply the product rule. Now what we do is we take this dy by dx, what we did here, and substitute into the equation 1. So therefore the LHS of the equation 1 will become v plus x dv by dx. Okay, as I did y equal to vx, I have to replace all y with vx. So therefore this will become x plus 2vx divided by x minus vx. Okay. Now I can factor x from numerator and denominator. I will get 1 plus 2v divided by x times of 1 minus v. Okay, x and x will get cancelled. Let's cancel the x's. This x and this x is cancelled. Then let's proceed. So basically we are getting 1 plus v. 1 plus 2v divided by 1 minus v. So this side we have v plus x dy by dx. Now we have to separate the variables. Separating the variables on both sides, we will get, first I subtract v from both sides, or I take the v to the other side. I will get 1 plus 2v divided by 1 minus v minus of v. So let's get this simplified. This is going to be 1 plus 2v minus v plus v squared divided by 1 minus v. So it's giving us v squared. Okay, v squared plus v plus 1 divided by 1 minus v. So this side we have x dv by dx. Okay, so we proceed from here. What we do is we write down this 1 minus v squared plus v plus 1. We write down this as v minus 1, negative of v minus 1, and this will remain as it is, x dv by dx. Now we separate v to the left hand side, v's to the left hand side, and x to the right hand side. So I'm going to write down this as v minus 1 divided by v squared plus v plus 1. This negative, this will become dx by x. That is, this will become negative of dx by x. Okay. This negative remains on the RHS only. Rest of them are taken onto the, okay, this side I forgot to put the dv. So here we have a dv. We need to put the dv. Okay. Now as we know that in variables we have separated the variables, we have to integrate. So let's do this, v minus 1 dv all over v squared plus v plus 1.
Partial fraction.
Yeah, let's see if we are going to do partial fraction. Okay, but for partial fraction we have to factorize this. This has to be in a factorized form. So we cannot factorize this. It's not a quadratic with which is factorable. We cannot do it. So we have to adopt some other methods. Okay, so let's see. Let's do like this. What we do is we are going to presume that if we have this in the denominator, right? V squared plus v plus 1. If I differentiate that, what is it I will get? V squared plus v plus 1 d by dv with respect to v. I will get 2v plus 1, right?
Plus 1.
I will get 2v plus 1. Do I have 2v plus 1 in the numerator? I don't have. But I'm going to convert the numerator as like this. For that I have to make some adjustments. Okay, understood? So let's see how to do this one. First, here I have v. So I need to have 2v. So what I do first is I multiply and divide by 2 by 2 like this. Okay, so then I transfer the 2 to the inside. Okay, so this I put 1 by 2 and then multiply by 2 to the inside like this. V squared plus v plus 1 dv. Okay, this side remains as it is. Maybe if you can easily integrate, is nothing but log mod x. I'll just write down as it is. So the next step, so I'll write down r 1 by 2. This is 2v minus 2.
2v minus 2.
2v minus 2 divided by v squared plus v plus 1. V plus 1 dv. Integration. Okay, I will put log mod x. Let it be. We have just integrated this RHS. So therefore this is going to be r. Okay, we already know that if we differentiate it, we need to get 2v plus 1. But I have 2v minus 2. So what is it I can do? I can add plus 3 and minus 3 with 2v minus 2. If I do plus 3 and minus 3, this will get me 2v plus 1.
2 meters.
Okay, so that's what I'm going to do. As I said before, we are making some adjustment, that is 2v minus 2 plus 3 minus 3. I have to add plus 3 and minus 3 so that it will not disturb the numerator. Divided by v squared plus v plus 1 whole of dv integrate equal to minus log mod x. Okay, so the next step, half of this, as we know, 2v minus 2 plus 3, I can write down this as 2v plus 1, and this minus 3 will remain as it is. So therefore I'll get 2v plus 1 minus 3, 2v plus 1. In fact, we can consider minus 2 I'm writing as, in the minus 2 I'm writing as 1 minus 3. Okay, 2v plus 1 minus 3, and v squared plus v plus 1 whole of dv integrate equal to minus log mod x. Okay, so now I can split this 2v plus 1 minus 3 into two parts. So half of this integration can be written as 2v plus 1 v squared plus v plus 1 dv. I split it into two integration, that is minus this minus 3 by 2, because this 1 by 2 is common for this integration. This will become as minus dv by v squared plus v plus 1. This is equal to minus log mod x. Okay, minus log mod x. Okay, now we just have to, we know that this is, if we make the substitution here, if we make the substitution for this to integrate, this is easy. That is what we have done. For the we already decided that we know why we are doing this one, because we are going to consider, if we differentiate this, we should have it in the numerator. So for that only we have done this adjustments, and finally now you can see this v squared plus v plus 1, the differentiation of this one is available in the numerator, which means I'm going to use this formula. Okay, the differentiation of this one is log mod f of x. Okay, so therefore this side it will become half of log mod. You can do t substitution also, but that is not required. Okay, since we already know this formula, log of mod of v squared, the denominator, v squared plus v plus 1. Done. The first one is done. But this one you have to do as like integrating the particular function v squared plus v plus 1. Okay, let me do for that one. I'm going to use a different color. So let's see, separate here. Let's do this separate here. V squared plus v plus 1. V squared plus v plus 1. This is, what is that? Okay, the method is we have to take the half of the v. So v squared plus v plus square of the half of it. Half squared minus half squared we have to do. So we have to do this half squared minus half squared plus 1. Already we have the plus 1. This I can erase. So now if we look at, we're just writing down in the completing the square. So v squared plus v plus half squared, I can write down this as v plus half square. Okay, and this 1 minus 1 by 4. This is 1 minus 1 by 4. Okay, which is 3 by 4 plus 3 by 4. It's a positive 3 by 4, that I can write down as root 3 by 2 square. Okay, so finally we have written this in the form of squares, completing the squares. Okay, this you understood?
Yes, sir. Yes, sir.
We done this. This is nothing but integrating the particular functions. We done this in earlier classes. Okay, so therefore this is minus 3 by 2. I can write down this as 1 divided by. Okay, I have to use the same color. So dv This denominator I have written as v plus 1 by 2. V plus 1 by 2 squared plus root 3 by 2. Root 3 by 2 square. Integrate. This side as usual we have log mod x. Okay. Okay. So it is like this. Okay. So then I just replace, I maintain this as it is, log mod v squared plus v plus 1. And can you tell me the formula for this one? This is x squared plus a, x
1
squared
by
plus
a,
s.
1 by a, tan inverse x by a.
Okay, so 1 by, instead of a we have root 3 by 2. So that you have to put here 1 by a tan inverse x by
X
a,
by
right?
a.
So instead of x we have v plus 1 by 2. V plus 1 by x by a is root 3 by 2. Okay, so this side is maintained as log mod x. Okay, now let's get this simplified. We have to simplify these things. Okay, this 2 and this 2 will get cancelled. This 2 and this 2 will get cancelled, and root 3 will get cancelled. Root 3 will cancel with the 3 as this one, root 3. And okay, so therefore half of log v squared plus v plus 1, and finally the coefficient here is minus root 3 tan inverse of, let's simplify this. I'll do it, and we'll get this simplified. This is 2v plus 1 divided by 2, and this is root 3 by 2, right? This 2 and this 2 is getting cancelled. So finally I have 2v plus 1 divided by root 3. 2v plus 1 divided by root 3, okay, equal to minus of log mod x, minus of log mod x. Okay, this one is not required. Okay. Okay, now what I do is I bring this minus log mod x to this side, to the LHS, so that I can combine these two logs. So I put 1 by 2 log of v squared plus v plus 1
By x.
plus log mod x. Log mod x, and this negative tan inverse root 3 tan inverse will become positive.
Positive.
Root 3 tan inverse 2v plus 1. Okay, so we have not reached the end of the solution. What is that missing? We have to replace v. It cannot be a function of v, because v is a temporary substitution. We know that y equal to v. We did this substitution, right? Y equal to v dot x. So v equal to y by x. So to put back the value of v. So therefore I can write down r half of, wherever we have v we have to replace it, y by x. Half log, this will be y squared by x squared plus y by x plus 1 mod. Okay, I can multiply these two logs times of, this is already x. Okay, I whole mod equal to root 3 times tan inverse 2v, 2 times of y by x, 2 times of y by x plus 1 by root 3. Okay, we can simplify further, or half log, so this will be, the common denominator is x squared, y squared plus xy plus x squared. This will be, denominator is x squared, and this will get divided, so I can put this as divided by x whole mod equal to root 3 times, we did a mistake here. Okay, what is that mistake? Can you identify the mistake? I cannot simply multiply this log mod x to this one, because this is a half, no?
Half. Yes.
Okay, so I have to change this. I have to change this to, how can I change this one? This log mod x I can write down as 1 by 2 x squared. Is this correct?
Sir, இல்லைனா நமக்கு 1 by 2 பவரா போட்டுக்கலாம்.
This you can put it as power of root 2, but it will come in terms of root 2. To let's avoid that one. Instead of seeing that as a whole, this We have three terms, we have to see it as a root, but here it is one term, right? So there is a purpose for this one. If you look at this one, this is x squared, right? These two x squared and x squared will also get cancelled here. Here it will become x squared. If you do like this, it will become x squared here. Okay, so this, in fact, this term will get cancelled. In fact, these terms will not happen. I'll rewrite it. So it is log mod y squared. Okay, y squared plus xy plus x squared. That's it. This x squared and x squared denominator will get cancelled. And this side we have root 3 times of. So this is equal to root 3 times of tan inverse of, we can simplify this, 2y plus x, 2y plus 1 divided by root 3x. Okay, so this is the final solution.